So Catherine, we're talking today about 3D printing, or additive manufacturing as it's known. Perhaps we could start by explaining what we mean by 3D printing, and is it the same thing as additive manufacturing?
Yeah, so it is the same thing. 3D printing is perhaps the terminology that's more used in the consumer environment, where it's home printers, home 3D printers. Additive manufacturing certainly is the industrial name for these processes. Various different ways, different technologies for achieving the same thing. Essentially, the difference between traditional manufacture and 3D additive manufacturing, 3D printing additive manufacturing, is that instead of, so traditional machine tooling, you start with a block of something and you basically carve back to the shape that you want. Or you start with sheet metal and you cut it out and you weld it into the shape that you need. So it's quite a complicated process, quite a lot of waste in both scenarios. 3D printing, you start with nothing and you build up. You have a digital file which gives you the shape that you want to achieve, and you build up layer by layer the shape that you want until you've created the object. Various different technologies to do that. The one that perhaps most people will have seen, hobbyists, craft people, that kind of thing, use it a lot, is where you have a plastic filament, like a plastic wire, that comes into a little heating zone, and the plastic will be melted and deposited to follow the shape of whatever it is that you're trying to build, and that kit will sit in a frame which allows 3 dimensions of movement, so forwards and backwards, up and down, side to side, so that you can move the nozzle in all of the places that you need, and it slowly moves upwards. That's one of the ways that you can achieve 3D printing. Another one is where you have a vat of resin and you apply something to the surface of the resin again, so that it solidifies. I think it could be UV light, it could be something else. And then you build up layer by layer, solidifying a layer of resin at a time, until you end up with the shape you need. And the technology that's used for additive manufacturing at sort of full manufacturing, commercial manufacturing scale, involves having a vat of powdered alloy, or a layer of powdered alloy, sorry, and a laser will then fuse the alloy, melt it and fuse it with incredible precision of micrometers, a precision of micrometers within incredibly short spaces of time, and huge differences of temperature across tiny spaces, so incredible precision. And the laser will melt the powdered alloy, again, layer by layer, layer by layer, layer by layer, until you build up the shape that you're after. So that's why it's called additive manufacturing, because you're adding layers. And there's a sort of reverse definition of the old form of manufacturing, which is now sometimes called subtractive manufacturing, because you take away the bits that you don't need.
So what then are the advantages of additive manufacturing over subtractive manufacturing?
So I've mentioned one already, actually, which is that you don't get the same kind of waste. You only use what you want. You only use what you need. Very often, the raw material will remain either reusable. You can put the powdered alloy back into the vat, use it again. You haven't melted the filament that you didn't need, etc. Because you create the shape that you want rather than taking away what you don't want, you can create some much more complex structures. So whereas previously you might have ended up with a block of something, with additive manufacturing you often end up with a sort of honeycomb structure. And that has great advantages because it may be much lighter, producing things in that way. You can achieve the same strength, you can achieve the same structural characteristics, but using much lighter. The overall thing will be much lighter. Another aspect is that you can create, because you've got this flexibility in what you're creating, you can create much more complex structures in a single block. And that can be really important from a sort of engineering point of view, because every time you join something, you create a structural weakness. And if you're creating something in a single piece, it can be much stronger than the old form of manufacture would be, and also it's much simpler to create something in one block. You don't have sub-assembly where you put 8 components and you bolt them together, weld them together into what you're finally wanting. If you can create the whole thing from scratch in one go, that's much simpler. And another really important feature is that because this is all driven by digital files, you always have a digital file telling the printer, telling the system what to produce. Changing your manufacture to produce this and then to produce this and then to produce this. You don't need to retool anything. You don't need to change your production line. You simply put another digital file into the system. And so there's much more flexibility around manufacture. And that means that you can justify having the manufacturing kit much more local to you, and that can simplify your supply chain, so you've got economies and efficiencies there. So there's lots of really significant ways in which additive manufacturing is very different in terms of the particular characteristics of the economics of using that system.
And what does that mean in terms of the things that are being produced, the uses for additive manufacturing? Where is it being used at the moment?
So one of the examples that I often talk about at the sort of full industrial scale is gas turbines are being made using additive manufacturing. So the blades in the turbine, they are being produced using additive manufacturing. There are some amazing statistics. So there's a 75% reduction in production time. There's a 95% reduction in repairs, and it's all because of what I was saying about the structurally stronger pieces, less structural weakness points, etc., faster manufacturing, etc. They're also being used in many sectors. There's a sort of full-on industrial example for you. Electric motors, also by the same manufacturer. In the medical sector, there are some really interesting uses. So orthotics for children, sort of braces and supports for children, used to be, well, traditionally the way to make them is to take a plaster cast of the relevant part of the child's body. The child will have to stay in hospital while it dries, it'll need to be cut off, etc., etc. Then they'll take the plaster cast away and they'll create the orthotic from that cast. That can take a few months. If the child's growing fast, it might not fit when it comes back, etc., etc. Using 3D printing, there will be a digital file taken, digital scan of the child's body, the relevant part, and the orthotic can then be made in a couple of weeks using 3D printing, which is really powerful if you think about it, because that's, you know, there's no problem with it not fitting anymore. It's done very quickly. All that sort of, you know, comfort and ease. It's technology bringing ease and simplicity to something, which is really powerful. Another application in the medical field, because I said that it's very simple to change what you're manufacturing, you've got that flexibility around what you're producing. That facilitates very small production runs, individual personalization, etc. Because the ease of changing from manufacturing to one thing to the other means that you don't have economies of scale in the same way as you do with production, where you've got a whole production line being tooled up. So if, for example, you have a nasty break, a nasty bone break, it's possible to scan, say, a broken jaw. You could scan the break area and produce a 3D printed replacement piece of biocompatible material to replace the missing bone, and that can be a perfect fit. It's scanned exactly to your body, etc. So some really powerful applications there. In the construction sector, completely different, we're seeing 3D printing type techniques being used to build houses. So instead of having plastic filament or something coming out of the nozzle, as it were, it's concrete coming out, and the concrete machine, the 3D printing system will again be set up in such a way that it's got three dimensions of movement, up, down, side to side, backwards and forwards, and it will go around and it will build the walls of the house. And again, that's an incredibly powerful application, because the kit that you need to achieve that can be very portable, can be very transportable. The output can be, relatively speaking, can be much cheaper than traditional ways of construction. So you can see that that's really powerful just in terms of fast building of houses, whether that's generally speaking to boost housing stock, or whether that's for disaster relief, where you can get shelters built very quickly, etc. So that's another example. And then perhaps, again, another completely different area, where we have food, sort of lab food, high technology food products being created. 3D printing can enable texture to be created into the product. So it's not just a lump of some sort of protein substitute or lab-grown protein. If you print it, you can create texture and feeling. And obviously with food, whether it's palatable is as much how it feels in the mouth as how it tastes, when you eat it, etc. So lots and lots of wide uses for this technology.
And that's where we are now, if you like. Where's all this going? Where are we seeing developments in 3D printing?
Well, so often the answer to that question is convergence, and that's true in this field again. So where the real advances are happening is where you've got different technologies coming together, and the sum of the parts is great. The outcome is greater than the sum of the parts, if you like. So with 3D printing, as with so much else, there's an artificial intelligence boost to all of this. There's a new technique called generative design, and one of the really good examples that I've seen, for example, in the back seat of the car, there will be a little bracket, quite an unexciting little piece of metal, and the seat belts are bolted onto it. So it's important, it's not very exciting, it's a little piece. At the moment, one example, for example, has 8 different component parts. So it takes a little bit of sub-assembly to get that into the right shape before you can bolt it into the car, before you can bolt the seatbelt on. Now what they did is they took that piece and they put it through a generative design system, generative design algorithm. They told it what the structural properties had to be. It had to be this strong. It had to have fixing points here, here, and here. It had to have spaces where there definitely wasn't anything. You had to have free spaces here and here. It needed to achieve this. It needed to achieve that. And they put it through the generative design process. And what the artificial intelligence system does is it completely rethinks the shape. So it comes up with a completely, they very often look very organic, almost very alien, these generative design pieces. And they're not the kind of shape that a human being, a human designer, a human brain would have come up with. They're completely different and they're very incredible. And they are very often much lighter than the original. As we were saying earlier, they can be printed in a single block using additive manufacturing systems. They're often just as strong for much lighter weight, therefore they cost less to make because you need less material, there's less wastage, there's variety and flexibility if you want to adapt them or change them, etc. And that's a really nice example of how artificial intelligence is creating these incredible new shapes which the particular properties of additive manufacturing make it possible to create. Because one of the other problems with these shapes was that without 3D printing, additive manufacturing, it would almost be a sort of craftsman that you had to create this extraordinary structure. But bringing the two together, it's really powerful and it's being used. It creates these light shapes, which means it's a really important development for the automotive and transport sector. Lightness is obviously important, and if you need an engine to make something move, then the heavier it is, the more power the engine needs. Now, as we move away from combustion engines into electric motors, for example, weight becomes very important. So if you can take out weight, even on a little seat bracket that you bolt the seat belts onto, that's important. That's sort of incremental gain. Take out weight here, take out weight there. It's affecting airline design as well. So there are, for example, the panels between business and economy on one aircraft manufacturer have been redesigned using generative design and 3D printing. And they're now a completely different shape. Internally, they've got not a sort of symmetrical structure, but a totally different shape, which achieves the same thing, much lighter. And there's an experimental aircraft which has got thousands of 3D printed generative design components in it, which again is affecting the weight of its positive impacts on the weight and the efficiency, all the rest of it. So some really interesting things. It's all around convergence, as always.
And I'm interested, we were talking about lots of different applications in the real world of things that have been done in a different way. Is that, and also talking about files on computers that generate things, are those sorts of things generating new legal issues that businesses will need to grapple with? So
yes and no. I mean, some of this is similar, is new applications for old existing law. So we're obviously in the territory where intellectual property is very relevant. Patents, for example, will prevent other people from producing a particular design because it's patented. There's an exclusive monopoly has been granted to that, and 3D printing doesn't change that. It makes it perhaps riskier that people might be able to infringe the patent, etc. But it doesn't make it any less. It doesn't change the legality, I suppose, is what I'm saying. There's an interesting question around spare parts. So historically, inventors often haven't really minded if people produce their own spare parts because it's not been done at any particular scale. It doesn't significantly impact the revenue streams from the patent, etc. There's a potential that 3D printing, because it creates the potential to reverse engineer, it possibly makes it easier to produce spare parts for a patented product. So it may be that there's a reaction to that to try and reduce that.
Possibly for a safety issue if you're...
Yeah, possibly also safety, absolutely. Yeah, absolutely. On the consumer law front, we've got a combination here of physical things, the thing that you've printed, the printer that you're using, plus also the digital files. And the consumer rights around digital files are They're certainly there, but they're a bit more complicated than the consumer rights around physical goods because they depend on how the digital file was passed to you. Was it passed with a physical product? Was it passed on its own? How was it transferred, etc., etc. So the consumer rights are there, but they're a bit more complicated. Labelling rules, I suppose if you have a situation where you're 3D printing something which would normally carry labelling obligations, then there's question marks about how you make sure that that's being complied with. And then down the line, I suppose, as the potential for what can be 3D printed develops, I talked earlier on about 3D printing of foodstuffs. If that becomes something that we start to do in our own kitchens, really real digital transformation, so that my online food order becomes some vats of stuff and some digital files to print it into the food that I want. We might need to rethink food regulation at that point because we've obviously got some completely different channels for these foodstuffs arriving with me, the safety, the requirements about allergies labelling, all those sorts of things. You can imagine that might need rethinking. So depending on how this develops, it may be, particularly at the consumer end of 3D printing, it may be that we need new regulations to deal with the different risks that get thrown up.
Catherine, thank you very much.